America's hazardous waste crisis has materialized because no one, government, industry, the public, fully realized how harmful some of our wastes could be. Who knows what wastes are in these 55-gallon drums? Eventually, they will rust and leak. It used to be common practice to pump hazardous wastes into makeshift lagoons to get rid of them. The toxic materials in these ponds could seep into the ground and contaminate groundwater or overflow during rainstorms. Hazardous wastes are generated from the production of paints, pesticides, plastics, leather, textiles, medicines, and many other products that we use in our everyday lives. The toxic and harmful qualities of these wastes are caused by chlorinated organics, heavy metals such as lead and mercury, acids, alkalis, cyanide, and many other chemicals. The challenge is to develop systems to handle the millions of tons of hazardous wastes produced every year, while catching up on the cleanup of abandoned wastes. Here, an industrial waste recycling plant receives solvent wastes from the manufacture of furniture, ink, paint, and other products. Impurities are removed, and the solvent can be restored to its original quality by a distillation process. Or more economically, the wastes can be blended into a fuel with properties similar to number 2 fuel oil. This one small plant can distill fuel from solvent wastes equivalent to several million barrels of petroleum a year. Another division of the company recycles waste oil. A sample is taken from an incoming truck to be centrifuged to determine the oil content. Waste oil becomes contaminated with heavy metals, dirt, solvents, and water, which can be seen in the bottom of this sample. Treating this waste oil could produce various products. It could be recycled back to its original use, or it could be converted to another use, such as heating oil. After chemical and heat treatment, another sample is taken to determine the oil's characteristics and whether it will measure up to American Society of Testing Materials and National Bureau of Standards specifications. Again, the ultimate degree of treatment is dictated by economic factors such as market demand. A final sample is drawn from an underground tank to measure the critical properties of the oil, such as viscosity. Whatever contaminants remain after processing are sent to the Industrial Liquids Recycling branch of the company for further treatment. A tank truck is loaded with several thousand gallons of high-quality recycled oil, which otherwise would have been a waste problem for the environment. Recycling and reuse is a better option than even the most competent disposal system. Oily wastes, acid wastes, caustic wastes are mixed in this tank in such proportions that they neutralize each other, with the oil eventually floating to the top. The sludge is drawn off the bottom of this sedimentation tank. The effluent is aerated and discharged to a publicly owned treatment works, leaving a sludge which can be disposed of in a regular municipal landfill. Hazardous waste managers must decide between recycling, treatment, or disposal. The best options are to reduce the amount of waste at the source or recycle them. But when hazardous wastes must be treated or disposed of, there are options which are legally and technically sound. A mountain of clay has been excavated from the earth to create hazardous waste landfill cells. Eventually, it will be used as cover material. "55-gallon drums are used as containers for solid materials. The drums are trucked in, sometimes from great distances. They are stacked compactly in the landfill cell, and then cover is applied to keep the rainwater out and keep the waste in. To prevent leachate problems, a plastic liner is laid on the bottom of the cell and covered with compacted clay. On the top of the cell, another plastic liner, more clay, and then an earth cover. In another large hazardous waste landfill, a loading platform facilitates unloading. This keeps at least some of the trucks out of the busy cell area. The contents of each truck and the packaging of the wastes are known in advance. This permits trucks to be scheduled efficiently. Some trucks do go down into the cell. It's a busy place, with loaders bringing in waste, trailer trucks being upended for unloading, wastes being placed, earth movers bringing in cover material, and bulldozers scraping the cover in place and compacting it. Landfill disposal is one of the major methods used today, accepting most types of hazardous wastes. Properly engineered landfills prevent wastes from harming the outside world. Inside each landfill compound is a technical support team. If mismanagement has been the problem, then proper management must be the solution. Large disposal companies which handle hazardous wastes have developed careful systems to ensure proper operations and to avoid accidents. A waste generator must fill out an application which provides chemical and physical data about its wastes. A chemist evaluates the data to determine if the landfill is authorized under a state or federal permit to dispose of these wastes. Often this assessment is then supported by lab work as an actual sample is tested to confirm or further determine its properties and characteristics. There are numerous tests. This one is a gas chromatograph analysis. A sample is injected, and as it is burned in the test unit, a spectrum of responses of differing amplitudes identify and quantify the various chemicals present in the sample. As a result, the waste either is or is not accepted at this particular hazardous waste facility. The next step takes place when the waste is delivered to the facility. Simple tests confirm that the generator has sent the wastes which were originally agreed upon. For instance, a litmus paper check can determine if the pH is in the proper range. A specific gravity test provides additional information. Today's federal and state manifest, waste analysis, and disposal procedures prevent random discharge of hazardous wastes. These functions are the start of cradle-to-grave record keeping to prevent repetition of earlier problems such as Love Canal and Valley of the Drums, and to protect public health. Lined ponds hold liquids awaiting treatment. Alkalis are on the left, acids on the right. At this facility, liquids are absorbed before disposal in the landfill cell itself. These are pesticide wastes. They're emptied into a pile of fines. The absorption process takes place until eventually there's no liquid left. Any liquid that collects in the bottom of the landfill can be pumped out through these leachate wells and reprocessed. Meantime, groundwater quality is monitored frequently in a ring of special wells that surround the landfill site. A more sophisticated liquid absorption system mixes the liquid wastes and the fines in concrete pits. The fines are delivered by a screw auger. As the liquids and fines are mixed together, they are homogenized into a composite solid from which the liquids do not re-emerge. These fines from cement manufacturing must be purchased, although they once were a troublesome, useless waste. Solids for the landfill. Injection plowing is another method of liquid solidification. Here, liquids are injected into the soil. When the waste has been absorbed, it is landfilled as a solid. A small plot like this can accommodate great quantities of liquid waste. Leachate sumps are connected to drains located at the bottom of the landfill cell. Any leachate is pumped out and treated. Here, an electrical pumping system removes leachate automatically. A hazardous waste landfill involves other special processing. For example, empty drums are still contaminated and must be crushed before being buried to avoid differential settlement or collapse of the final cover. Many contaminated items are often delivered for disposal. These hoses must be buried. Only a few landfill cells in the United States are certified for disposal of PCBs. This is one of them. It is 80 feet deep, and below there is still 620 feet of dense clay. High-temperature incineration reduces the volume of wastes. Flammable liquids are burned in this air vortex stationary burner. Solids can be incinerated in this rotating kiln. High-temperature incineration can provide more than 99% destruction of organic hazardous wastes. These temperatures range from 1200 to 2300 degrees in the two burners and the afterburner. Emissions from this stack contain very low levels of particulate matter, low enough to conform to federal and state standards. What you see is almost entirely steam. This Venturi wet scrubber is an important part of the incinerator's particulate control system. Cooling water is recycled. Even with incineration, however, a residue or ash remains, which needs to be disposed of, usually by landfill. Deep well injection is another hazardous waste disposal method. Wastes, such as acids, pickling solutions from plating operations, and plant water contaminated with heavy metals, are contained here in lagoons first, and then in tanks. Finally, after filtration, pumps inject the liquids at about 130 gallons a minute into porous formations. At this site, these disposal zones are about 4,500 feet deep. Low permeability layers of shale and clay lie above and below the disposal zones. Underground injection is only possible in certain areas, however, and current capacity accounts for only a small percentage of the total hazardous waste disposal problem. An effective and efficient method of disposing of biodegradable hazardous wastes is called land treatment. Liquid wastes are plowed into or spread on the soil and then cultivated periodically. Sunlight, chemical and biological action produce changes. After 5 days, still an oily mess. After 9 days, conversion proceeds. After 2 weeks, a brownish soil once again. These fields are actually a waste treatment medium, serving a function similar to aeration tanks of an industrial wastewater treatment plant. There are certain advantages to land treatment of hazardous wastes. In warm climates, biological activity in the soil is accelerated, and there are no moving parts except the application truck and the cultivator, which hastens the biological action. Land treatment of biodegradable hazardous wastes, an emerging technology. Precision reporting is the new rule for hazardous wastes. Landfills and other facilities maintain tight security. Every shipment of hazardous waste off-site activates a manifest system which will follow wastes from their point of origin to their predetermined point of disposal. The law specifies stiff penalties for violators. The weighing station determines the quantity of waste to be processed and thus the cost. This can be substantial, a factor that motivates manufacturers to segregate waste streams, treat hazardous wastes, and maximize in-plant recycling. Truck drivers find they have new responsibilities. The driver presents the generator's manifest, which lists each type of waste and the quantities. The manifest forms have multiple copies for everyone concerned. A safety sheet is provided for the worker who must unload the truck. Paperwork to prevent carelessness and irresponsibility. Everybody wants wastes to be disposed of, but not near them. Thus, waste management is not only a technical and economic problem, but a political one as well. These people are braving the weather to picket a landfill near their homes. And of course, the emotional intensity is heightened even further if the facility is intended to handle hazardous wastes. But citizens, waste generators, and community officials must attempt the sensible objective of disposing of all types of wastes efficiently and effectively. Citizen leadership is needed to develop positive solutions which are acceptable to them and beneficial to their community. Proposed sites must have good design characteristics and safe locations. This landfill, for example, is located on a large industrial site and in a thick bed of low permeability clay to protect surface and groundwaters. Another landfill in a good location. And still another well-chosen site, sitting atop 750 feet of low permeability clay. Landfill site selection and approval is most likely to be successful now that all landfills must meet strict engineering criteria. A quarter of a century ago, burning dumps blackened the sky. Today, waste management is more sophisticated. Hazardous waste management requires detailed information on the waste itself in order to select the best options. Options to protect human health, provide safety, and conserve a wide variety of environmental resources: air quality, floodplains and wetlands, endangered species, surface water, groundwater. The public expects a sophisticated and competent program of hazardous waste management, which utilizes new scientific methods to provide optimum environmental controls. Today, hazardous waste options include reducing waste at the source, recycling wastes when possible, and properly treating and disposing of the remaining fraction, all in the interest of environmental harmony.